Okay, we left off here. I hope you went and did this assignment. I do need to have these assignments from you guys, okay? They're being graded and they're part of your homework and part of your assignments, okay? Helps you with your grades. Okay, let's go on to analyzing them. Alright, so the purpose of the control chart is what we really want to look at is it in control or is it out of control, your process? So can you find random pattern characteristics? Then you're in control within the upper control limit and the lower control limit. You can have these outliers, so those are going to be giving you that special cause variation, so you do need to look at those and figure out what the cause of variation is and then do some corrective action. It is not enough that all or most of the data are within plus or minus 6 sigma. You can still be an out of control process, so we're going to talk about that. So let's talk about these different typical out of control patterns, alright? There's another company called Western Electric, and we're going to get to them in a few more slides, but they basically, these are the types of systems that they've looked at too. So you can have points outside control limits, sudden shift in the process average, cycles, trends, you hug the center line, and you hug the control limit. So let's look at them. There's a 0.3% probability of any of these circumstances occurring though. Over much data. Now let's look at the shift in process average. Here you can see that all of a sudden, this pieces of data over here are now shifted up. That comes when you find at least 8 points above or below the center line in a row. Let's go to the next one, cycles. Here, you can see a pattern. You have 14 points in a row alternating up or down. See how this is going? This is pretty crazy here. So this is showing you that you are having these cycles. Systematic error, maybe P or T fluctuations. Okay, look at the trend. When you do these, okay, you have 8 points that run up or down, or at least 6 points in a row, steadily increasing or decreasing. If you draw a line through this data, like the average, you try to figure it out, this is what you would get, and then you can see a pattern there. It's usually due to gradual wearing out or deterioration of your tool or machinery, worker fatigue, or accumulation of waste products. Hugging the center line, stratification. This is when you have 15 points in a row inside of the 1 sigma limit. No variability. This could be due to an incorrect calculation of a control limit. Maybe you don't have really good sampling. Although, I mean, this is really what you're looking at too. So I don't quite understand this one. I didn't understand it last time when I taught this. I wasn't too sure about it. Okay, hugging the control limits. So you can have these points jumping here. So you have 8 points in a row on both sides here. See how this is? These are all the way outside of the center line. So Western Electric, these are those rules I was telling you about. They came up with some decision rules for detecting out-of-control conditions on control charts. They were decided upon by a committee in manufacturing. So their rules are non-random patterns. So let's look at this. This is everything we've talked about. Stability analysis rules. So 2 or 3 points above 2 sigma, 4 or 5 points above 1 sigma, 2 or 3 less than on the other side here, okay, and then 8 points above the control limit, or 8 points below this, okay, the center line, I'm sorry, CL, center line. So 2 or 3, here's some of their non-random patterns. 2 or 3 consecutive points outside the 2 sigma warning limits, but still inside the control limit. 4 or 5 out beyond the 1, and then 8 in a row on one side of the center line. So if you use the Western Electric rules for detecting out of control, it will enhance your ability to up the control chart to detect small process shifts. Charts for attributes. Now we're going to talk about the different charts. So when we're looking at P charts, so the next activities that you'll have to do in D2L will be creating a P chart and then the rest of these, an NP chart, a C chart, and a U chart. You will have an Excel program. You click on the activity and it's just going to tell you to generate it. Just take that tab of information, you go to the tab, it'll say P chart. You take that and then just run the P chart on that, okay? Because it'll already have given you the fixed sample size or variable sample size. So what it'll do is it'll give you this attribute data in your Excel chart, yes or no type, and it'll go and give you a minimum sample size of 30 to 50, and it can be fixed or variable, and then it'll give you the data. So if D is the number of defective items in a sample of the size N, then the sample fraction defective is this P is equal to D over N, and that's just one of the information they give you here. So this is defective would be about 20% here, and this percent defective. Okay, this is giving you this information here. Alright, so you're going to go into D2L. I'm going to run through all the different ones you're going to be looking at, and then you can run and do that. And then here's another P-chart training video. So make sure you look at that right down here. They don't take long. I'll put that outside as well, but it'll also be in the regular PowerPoint. And then here's just an example of what would come out of the data that you've collected that you'll have done in Excel. Using variable control limits, use control limits based on average size sample. Now the NP chart you're going to create, again, attribute data, yes or no. You look at the number of non-conformances in the sample, and they give you the data in this Excel spreadsheet. It tells you how many non-conformances you have. So the difference between the P chart and the NP chart, the sample size must be constant for an NP chart. Number rather than a fraction or a percent of defectives, and the calculation of the control limits is different. And again, all done by Excel. So again, here's another one on creating an NP chart. Follow the directions in D2L for this. So that's the second of the charts you'll be making. Here's an example. Non-conforming chart. The C chart. This is attribute data now. Counting type. You look at the variation in the number of non-conformances in a constant sample size. So what's the difference between a C chart and a P chart? The C chart accounts for the possibility of more than one non-conformity per inspection unit. So it requires a fixed sample size. The P chart is simply a pass or a fail, while C gives you the total number of the defects. You're going to create the C chart in Excel. Same thing. It's all one Excel spreadsheet, and there's different tabs. So there's at least 4 pieces of data to create 4 different charts. And here's another example of how to do the C chart. And here's some more data on it. This is your number of defects, and then the lower and upper control limit in the center line. The U chart. The U chart is another piece of attribute data and is counting type, and it looks at the variation in the number of non-conformances in the sample that does not remain constant. Okay, and then you're going to create a U chart in macros. Okay, I didn't see a little help on that one. All right, and this is what it would look like. Again, your graphs are going to kind of look like these, so just make sure you do. So remember, when you're collecting your data, we're coming back to this chart again. Type of data. Do you have variable data or do you have attribute data? If you have variable data, you'll be creating these types. X bar R or an X bar S, maybe a moving average R. If you have attribute data, you'll be creating an NP chart, a P, a C, or a U chart, okay, depending on, again, on which way you go down this flow chart. So this is a flow chart, one of which of the many tools that you do in this quality. Okay. So the quality goals are to be plus or minus 3 sigma, and that is, puts you 99.73% of the time inside the range. Then on the other side you have a 0.275% of output outside the range, possibly 2,700 defects per million. Plus or minus 6 sigma, this is inside the range. Crazy. You have about 3.4 defects per million. Way different, huh? And I don't know if you remember, but Mr. Holman said that 6 sigma is really, really hard to get. It doesn't seem realistic. They shoot for 3 sigma, which will really tighten up your ship as well. Okay, so then we have 2 more control charts that you're going to work on. You're going to make a product brightness control chart. And what can you conclude? So there's some going to be information, okay, in there. Will be combined with it. Again, this is just information that will be in your activities to be graded. And then you're going to run a reaction runtime control chart. And what can you conclude? So again, there's another Excel spreadsheet with all the data in there, and then the activity in D2L. So this is your assignment. The company produces a product in granular form. One product response of interest to a customer is a product brightness. So brightness is measured. They have this different, and there's a subgroup of 4 selected, the data from 20 hours. So what you're going to do is you're going to prepare different types of charts for all of these, okay? You'll prepare a range and X bar chart, and you may also be creating a P, NP, and so on, okay? So you're just going to look at them and just see how different they are. And then you're going to do a reaction runtime. Same thing here. The data's there, okay? So this is quicker. Be sure to complete your activities to be graded, okay? Make sure you read Chapter 18. Complete your homework assignment, and then continue to work on your quality project. If you need any help from me, again, let me know. If you need, oh my gosh, if you need to oh my gosh, I just did the whole thing. And so this should be the end of this lessons for today. And again, let me know if you need any help. And I'll talk to you soon.